This is another example of determining the numerical coefficient of a given term with this literal coefficient for the expansion of a plus 2b with the n or the exponent equal to 30. You can use here the actual expansion, but you would need a lot of terms. For our n be equal to 30, you will have n plus 1 terms. In short, you will need 31 terms here. And that's for the expansion alone. But we don't need the actual expansion because we just need to answer or give the numerical coefficient of x to the power of 18 and y to the power of 12. In short, simply plug that in here. So you will have here the summation. This is actually for the general or the condensed form of the binomial expansion. N taken r, x to the power of n minus r, y to the power of r, as r starts from 0 to n. So since we know that our n is 30, that's the exponent for our expansion, the next part here is determine our r using this form, and the idea that we're looking for x to the power of 18 and y to the power of 12, partnering that here, you will get r which is equal to 12. This is the r we need to use here for our condensed form and to get the to help us get the numerical coefficient. You can also use the relationship of these two. N minus r is equal to 18 rather, and n is actually 30 minus r equals 18, so r is equal to 30 minus 18. You will still get an r equal to 12. So we're really sure that r is equal to 12. Now, we won't be using the summation itself because we just simply need to look at one term, because summation of this entire expression would give us the actual expansion of the 31 terms. So we simply need to look for n taken r, x to the power of n minus r, and y to the power r. As soon as we will get the coefficients for x to the power of 18 and y to the power of 12, that will be our result now. But take note, our first term here, our x, because this formula is actually, the formula here is actually expansion for x plus y. So for our given here is a plus 2b, our x is actually a, and our y is twice b. That would mean we'll be subjecting the numerical coefficient of b, which is 2, together with the exponent of r, not just b alone. In short, for this, you will have here n, which is again 30, combination 12 as your r. Your x now is a. Of course, you will n minus r is already identified here, to the power of 18. And your y is not just b, but more importantly, it's actually twice b raised to the power of 12. That's our target here, this one. In short, our numerical coefficient is not just the result for this given combination form, but it also includes 2 to the power of 12 as we apply the laws of exponents. So let's continue here at the bottom. Again, this is what will happen here. 30 combination 12 is actually 30 factorial over 12 factorial times 30 minus 12 factorial. Okay? Then a to the power of 18, and you will have here 2 to the power of 12 and b to the power of 12. So you will have here 30 factorial over 12 factorial times 18 factorial. You have 2 to the power of 12, a to the power of 18, and b to the power of 12. This is actually, I'm so sorry, my given is incorrect. Yeah, my bad. I will edit this one here because my given is incorrect. It should be actually for, I'm talking about, this should also be a and b. Okay, so this is a and that is b, so that we will be guided that it's actually a to the power of 18 and b to the power of 12. Pardon with me with that because I have noticed that we already arrived to that one here, and since our given are expressed in a and b's, we don't need x and y's. Just for the formula itself, we just need x and y's, but we have substitution here already. So pardon with me with that. So I'm going to edit that in, I mean, this is already okay to stand it here. Please bear in mind if I have made mistakes a while ago. So to continue that, so we will have here the result for this. Okay, so we simply need to look into the result of that using your calculators. If you have calculators there, You can help me verify here, because I'm also going to use 1 here for me to make a better answer, because I don't want to make incorrect results that might confuse you. We have 3 combination 12. Okay, I'm going to use my calculator here, is not the 3, rather 30 combination 12 is equal to 86,493,225. Okay, so this is the result for the combination of 30, or 30 combination 12, or 12 taken from 30, times 2 to the power of 12, or let's give the value for that, 2 to the power of 12 is actually equal to 4,096. Okay, so 4,096 here. Again, it's actually a to the power of 18, b to the power of 12. We don't actually need this, but I'm just rewriting that because we are actually, for us to be guided. My point of not necessarily needing that is on the fact that we are just looking for the numerical coefficient. Okay, so just the numerical coefficient. As we multiply now these two, so you have here 86,493,225 times 4,096. It would give us a result equal to 354,276,249,600. This is now the numerical coefficient for the term a to the power of 18, b to the power of 12 for our expansion of a plus 2b raised to the power of 30. As you can see, it's very large. If you would like to try Pascal's triangle or even the actual expansion, it would take you a lot of time because you're expecting 31 terms. But just for the formula itself, for the binomial theorem, taking out the intended and the correct n and r, so you will have this result for this specific item. Again, pardon with me if I have made some errors earlier here as to the representation of x and y, but we will be correcting that. Nevertheless, the answer here is correct. Thank you very much for watching.